Can we see that? My slide?
Yes.
Okay. All right, Melissa, should I just start them?
Yeah, go ahead.
All right, we'll start. Okay, everybody, we're gonna start the short course. So first, welcome to all of you. We're having some technical issues with the live stream, so those of you who are waiting for that aren't hearing this. You'll hear it later on the recording, but Melissa will send you an email shortly, I'm sure. So you've seen this before. It's just how the 3 days gonna go. We spread the course over 3 days this year, Tuesday, Wednesday, Thursday. And each day has 2 sections with 1 hour break. So we're going to start now, 5 minutes ago, and go on for an hour and a half. And then we take breakfast or lunch or dinner break, whatever that is for you. And then we continue on with the second longer half of the show per day. So today, you've seen it before as well. We're in the middle of the 10-minute welcome. That's going to be 5 minutes by me. And then we're going to do a little bit catching up on Unix and Bash scripting. If you've seen this before, just don't fall asleep completely because suddenly we're gonna do something active. But if you haven't done much Unix and Bash scripts, Max will go over the basics of the things you need to do. We'll have a brief coffee break or some bathroom break, and then we'll continue with sort of basic intro GMT stuff, capabilities of how to make very basic maps, how to plot the coastline map, that sort of thing, very basic things. And then that is broken into 2 parts with the hour lunch, breakfast, dinner break. And then we continue with a little bit more GMT basics before we switch to how to plot vector data, so symbols, lines, polygons. It can be done by Joachim. So Max will take care of the first half, basically. And then we end up with how to plot grids and images with Federica towards the end. And then I'll think of something to say for a few minutes, and then we'll call it a day, go to bed or go to breakfast or whatever time zone you're in. We know we're over many, many time zones here. So that's sort of the basics of what we're going to do today. For each of the topics, there will be a little bit presentation from the instructors about the topic to sort of set the background, perhaps. And this will vary in format. Some will be pre-recorded videos, others will be live talking from slides or from web pages or doing things. And then we will go into breakout rooms to actually practice this thing. So in the breakout rooms, there will be 1 instructor per room. And we can interact more directly with you in the breakout rooms. If you're stuck on anything, Slack is a good medium to contact us. And one of us will try to get to it. You could also use the chat, but it's easier, I think, for us to see the Slack channel activities. Yeah, I think that's really all I need to say, because I talked about the layout of the course last week, whenever it was, the 29th of June. The other instructors who are on this call, most of them are here. Anything I forgot to say that's important before we pass the baton to Max? Going once, twice, and third? No, I guess I either said everything or no one hear from me anymore. That's fine. So I think we'll give Max 2 more extra minutes, I guess, as a bonus here to start on the Unix Bash stuff. So take it away, Max.
Great, thanks. Can you stop?
Sure. Yep, absolutely.
Paul, can you confirm that you can see this?
Yes.
Okay, great. So in this about 25-minute section, we're going to go over some basics of Bash and Unix. And we'll just cover some really simple components. Bash scripting can get quite complex. And if you want a more comprehensive introduction, the Software Carpentry's Shell Novice course is a great resource to review. In this section, we'll have 7 slides that cover some fundamentals of Bash scripting, and then we'll go over in Visual Studio Code some examples of how to use Bash commands to interact with your operating system. So Bash is one of many different shells you can use to interact with a Unix operating system, and it's the one that we will be using for this course. If you're on a Linux or Mac operating system, this would typically be done by opening your terminal or running scripts. On Windows, you'll use Bash emulator. My favorite one is Git for Bash, but there are many different options there. So let's get started. In this presentation, we'll cover these particular topics. We'll look at how to navigate your directory tree. So this is analogous to if you're in your file explorer and you want to open a different folder or navigate to somewhere else. This will be how to do that using or through the command line. We'll also cover fundamentals of redirection. So piping or appending the output from a Bash command to, say, a file or another program. And then we'll cover how you can examine the contents of a given directory. And importantly, how to create and destroy files and directories, which will be essential as you create scripts that will control the flow of different GMT commands. And the last 2 concepts we'll cover is running your scripts from the command line, so using those files we just created, and then setting and using shell variables, which is important for reproducibility and having more effective control in your GMT scripts. So let's get started. The first command that's important for you to know is the change directory command, or CD, and the PWD, which is for print your working directory. So these are how in your terminal you can navigate to different directories using CD. There's a few different shortcuts you can use. For example, CD ... will navigate you to the parent directory, or you can use the tilde to go to your home directory and any subdirectory under that by typing in what's next. Redirection is fundamental to Unix programs, which typically operate by reading an input from standard in, which is oftentimes your keyboard, but can also be other formats, and writing to standard output, which will be displayed on your terminal, or to standard error. And you can redirect these outputs, which is what we'll be showing you in the live portion of this section. And so in this line, you see some of the common commands for redirection. So these arrows will either redirect from standard input to a command or redirect standard output. And the bar is for piping. So that's how you can redirect the output from one command into the input from the other. And this will start to make a lot more sense once we go through the examples. This is pretty fundamental to scripting using Bash. The ls or list command is how you can examine the contents of the directory you're in. And there's, for most Unix programs, you can type the command, so ls for list, and then a flag. So for example, in the 3rd row here, we see ls -l. So this -l flag will give more information about the outputs. And you can also use wildcards, so these stars, to modify the behavior of the program that you're using. Similarly, as we saw, the arrow to redirect the output. So you'll have the list command specifying all PDF files, and you'll redirect it to output. And these different options we'll go through in more detail again in the live section. You can also pipe the output to other programs using the bar symbol. The commands for creating and destroying files and directories include mkdir, rmdir, and rm. mkdir will create a named subdirectory in the current folder where the word that follows mkdir will be the name of the directory. So here dir would be the name of the directory. rmdir can be used to remove that directory as long as it's empty. You can also just use rm to remove the named file. And this -f flag will specify that it should be forced to delete it. And so this is a bit of a dangerous option because you won't get any prompt asking you to confirm that you in fact do want to delete that file that you specified. So it is sometimes considered living wildly if you specify this -f on the terminal. However, it's often used in scripts because you might not be there as the script is running. If you have, for example, a very long script that's set to run overnight or over the weekend, you don't want to return to find that it waited 3 minutes in for you to confirm whether you wanted to delete a specific file. So it's both useful, powerful, and dangerous to use -f flag to force the Unix command to take a particular behavior. Even more dangerous, you can use -rf, which -r is to specify recursive. This is something that, depending on your experience level, you may want to avoid. So those examples, you could either type into your terminal or your bash emulator to have a one-time command, or you could add them to a script. And so you would create a script and add different commands. So for example, list all the files in multiple different directories. And after creating that script, you would want to be able to run the example. It's important to have these skills. There are many different ways that you can specify that you want to run a bash script. The first thing you need to do is make sure that the bash script is executable. So on a file system, there's various permissions: read, write, and execute. And you need to make sure that execute permission is set to on in order to be able to run your script. And so this can be done using the changemaod command, where +x sets that you will be adding execution permissions and then the name of your script. And then you can run the script in several ways. And we will be using the first way in this course. It is the simplest and least likely to run into any problems. So we'll just be specifying bash and then your script name. So you're giving your script name as an argument to bash. The last section we'll cover is setting and using shell variables. And this is done using the syntax variable equals value. So here you're setting the value component, the right side of the equality, to the variable name. As one example here, we have the variable name width, which is assigned to hold 15C. And this character string is an example that could be used in a GMT program to specify the width of your figure. If you want to inspect what a variable has been assigned to, you can use the echo command. So here we have echo, and then you have wrapped in quotes string, but notice this $sign and then brackets and width. And so that is what specifies for the bash interpreter to look for the variable width and substitute it inside of that $sign brackets width. So rather than seeing echo map width is $sign brackets width, you'll see map width is 15C. And we'll see this in an example on in the interactive component. The last thing to note is that you can assign the output of a command to a variable. So in this last example, we have last PDF, and we're assigning it to the output of the command that's contained within the parentheses. So here we're getting the last modified PDF file, and we're assigning it to the variable PDF. So let's take a look at some of these in a little bit more detail through an example. So I will take a minute just to pull up Visual Studio Code. And Paul, if there's any questions or comments that came up in the Slack that you think we could address, now is a good time. Okay, so throughout this course, as Paul mentioned in the introduction, we'll be using Visual Studio Code. And so here you should see my VS Code window. Is that correct, Paul? Okay, so in just a quick layout, we have whatever files open here in the main window, navigator for files in this browser, and then open editors. And for this section, we want to show some bash examples through the terminal. So to get a terminal, I can go up here and go new terminal. And so now you should all see a terminal window below the general README, and I will make this a little bit bigger. If anyone needs any increase in the size, please post on Slack, and then one of the instructors can notify me. Joachim, go ahead. Did you have a question? Okay. I saw a hand raised, which was the pause, but we'll continue. So now we have this terminal, and we can view some of these different commands. So let's start by investigating where we are. So we do that using pwd for present working directory. So you can see from the output that I am in the GMT for Geodesy repository that I have just inside my home directory somewhere. So if I wanted to instead navigate to my home directory, I could use that tilde. So now I am in my home directory. Say I wanted to navigate back, I could copy this path. Now I am back to where I was. You can also tab up to go to previous command. So here I'm pressing the up arrow to go up to back to the command where I navigated to my home directory. This is pretty simple, probably would have been faster to type it, but in some cases when you're doing more involved commands, it might be useful. So I want to see what is inside of this directory. So I will use the list or ls command. So I can see that there's various folders. And these folders are the contents for each of the sections. So if you didn't do the homework and already cloned the repository, you will probably want to either navigate to these sections through GitHub or clone it now. And I will note that inside of each of the folders, so for example, one bash, there's a markdown README file, and that's where you can find a link to the slides that were presented in the first section of this section. So if I want to only list specific files, again, I can use that wildcard. So this would list all files, but I want wildcard.md to only list markdown files. So now rather than a list of all the files, I have a list of only the 2 markdown files. I could do this for any type of file. So for example, .sh is the suffix that's typically used to specify bash scripts, but I find that there are actually no bash scripts in this directory. If I want to sort on time, I can use the -t flag. So now these are sorted based on time. And say I want only the most recently edited file or directory, I would use the head command, and I only want one output, so -n1. So now I find that the contents of 2 basics have been modified most recently. So this is an example of piping the output from ls-t to an input, or as the input to another function, head, and then the output from that gets put on to standard out or displayed on your terminal. So this is an example of piping, which is pretty fundamental to effective bash scripting. So now we want to create a new directory to play around in. So I'll use mkdir to create a directory, GMT scripts. So now ls shows that we have a new directory, GMT scripts. If I had more files and I didn't want to have to visually sort these to try to find GMT scripts, I could start typing GMT and then tab complete, so press tab, and it will automatically complete up to the unique setting. So if I had multiple directories, it would only complete to the section where it would require input to know which one to complete to. So now let's go inside of that directory, so cd GMT scripts. And if I now type ls, I find that there are no contents within GMT scripts. Instead, I can do ls ... to report the contents of its parent directory. So that would be the root directory for this repository. And so we again see the contents of the GMT for Geodesy repository. Rather than, if I want this recorded, rather than printing to standard output, I could redirect that output to a file. So I'll do ls ... to list the contents of the parents directory, and then I will append this to a new file, list.txt. So over here we have this browser, and we can see that right now there's no contents in GMT scripts. After I run this, there is now a new list.txt file, and if I open that, I can see that it's the same output as was printed on my terminal, except now it's ordered one item per line, which can be quite useful. If I am not working in VS Code where I can easily click on this file, I can use Unix commands in order to report the output. Two common commands that are very useful for inspecting the contents of files are more. So for more list.txt, it reports the output of the file and has interactivity where you can say this had many more lines in it. You could, you would be prompted to press enter in order to print more lines. So you could control what you want the display to be in a little bit more granularity than the other common command for printing outputs from file, which is cat. So this will display the entire file. So I just typed cat and then tab completed list.txt. And so now the contents are printed to standard out. So if we want to, so this command created the file list.txt. If I run it again, I see no change because having one forward arrow here means clobber that file and put the output from your command into it. Say I want to add to that file versus replacing it, I will use two arrows. So now we will see that the output from ls ... is appended to the first output from that same command. So one additional useful command that you might want to use is word count, or WC, and number the flag -L will report the number of lines. So here we can use it to report that there are 22 lines in list.txt. And if we again append the output from list to this file and then do word count, we can see that now there are 33 lines in it. Whereas if we did the single forward arrow for recreating or deleting and writing rather than appending, we now see that there's only 11 lines in that file. So we don't really want this file, so or this folder. It's not going to be used again in this short course, so we want to remove it. And again, there's a couple commands that are useful for removing files, rm and rmdir. So this is a directory, so let's try rmdir for GMT scripts, but it doesn't work because it's not empty. So rmdir can only be used to delete empty repositories. So there are a couple options. One, we could go into GMT scripts again, remove list.txt, and then navigate back to the parent directory. And once again, try rmdir for GMT scripts. Or if we go to the parent directory, we can use that rm minus rf for GMT scripts, which would force delete all of the contents. If we leave out the f, you would typically see a confirmation. I might have some weird setting that did not confirm that I wanted to delete all those files, but that is what off the bat you should have some sort of confirmation that you in fact want to delete the contents of GMT scripts and the directory itself. So the last component we want to cover in this section is variable definition. So to do that, again, we will write the name of the variable we'll have the contents assigned to, and then the equality for what will be assigned it. And I'm going to clear the output so that we are starting fresh. And the shortcut for clearing the terminal output is very useful and is operating system dependent or keyboard dependent. So I encourage you to just look that up for whatever system you're on. So to assign a variable, we'll do width equals 15c as we saw in the presentation. And now we have, if we do echo and then $ bracket width, we should see 15c. Say there was no, if we instead specify a variable name that we haven't set, we'll get a null result. So now, those are the simplest way that you can set a variable. This is now contained within your environment. You could also do this inside of shell scripts. So let's do that real fast. So this touch command will create a new file. So touch bar.sh, we now have a new file that will have a bash shell script in. And so we want to, this is something that will be covered in the next section. So I'm going to specify this, but you can ignore this line right now. So now we have inside of our script, we'll have width 1 is equal to 20c, and then echo width 1. And now we can do bash bar.sh, and the contents, that script was run where we assigned the string or the character string 20c to width 1, and then reported that variable assignment using a $ and brackets with the variable name. So that is a very quick and basic overview of bash scripting. If you have used all those commands before, this is also probably all seem very simple. If you haven't, it might seem like a lot of information. So please remember that inside of this one bash folder, there's a README where you can reference these slides. And so that will be a useful resource for you moving forward, so that you don't have to remember off the top of your head which command you need to use for different things. So that was the first section. Welcome to the course. And we're going to take a quick break before actually getting into GMT. I'll pass it back to Paul in case he has any announcements.
Oh, that's great. Great, Max. Thanks a lot. So yeah, so that's sort of how the first goes. We're not going to have breakout rooms to just try ls commands, obviously, but we will do that once we get into the GMT side of things. So yeah, so right now we'll just take our 10-minute break, and we'll start, what is that, 3:15 sharp UTC, I think, in 10 minutes, 12 minutes. If you have any questions or anything that was unclear, just ping us in the channel on Slack or in the chat here. Otherwise, we'll see you in 10 minutes. All right, the next section is going to be first tackling GMT basics, and it will still be Max who running the show. So take it away again, Max.
Okay, so this section will follow a similar layout. For the first part, we'll have a presentation going over some fundamentals of scripting using GMT. And then I'll do a live demonstration so that you can see those concepts in action. But then we'll get into the funnest part of the course, which is the breakout rooms where everyone can try out these concepts, and there'll be one instructor in each room to help you along the process. So let's get started with the presentation section. So we have just a few slides going over some of the fundamentals of GMT basics. And there's a lot of resources out there for using GMT. And these are the resources that you'll probably refer to the most often. So to start out with, we have the GMT documentation. This is really fundamental. It's not likely you'll remember all the different options for GMT. It's a really powerful and can be complex program. So you'll oftentimes want to refer to the documentation. This link in the slides will take you there. Again, through the GitHub repository, you can find in the README a link to these slides so that you can access these links yourself without needing to type them in. But we'll show a quick preview of the documentation. So this is where that link takes you. And this is hosted online. You all should be using GMT 6.4. And if you update later on for future releases, this toggle menu is how you specify which version you want your documentation to be built for. And there's a few different useful, particularly useful pages in this, and they can be navigated to easily using the quick links. So one of them is the common options. So if you click here, you're taken to the common options, which are arguments for GMT that are used throughout different, GMT modules, and mean the same thing. So these are options that you'll have to use option, and you can go to this table to be quickly taken to the documentation for each one. Similarly, the default settings page is very useful. This is how you configure your processing parameters and map appearance. So this default settings link will take you over to gmt.conf. And here you have a table that contains the links to the definitions for various GMT parameters. So for example, if we go to font, you see the name of the parameter, so font, and the definition. And there are many. You might want to read through this once, but in general, you can go back to this page and maybe search for a keyword that describes what you want to control for your GMT setting. All of the documentation that we'll be referring to is in modern mode, and that prior to GMT 6.0, there was only one mode, classic mode. Here we'll be focusing on modern mode. This is only relevant if you have been using GMT for a long time, and if you if you happen to be in that situation and you need help, please reach out over Slack. For this, we'll be assuming that everyone starts from a clean environment or knowledge base, and will only be using modern mode. So for this section, GMT Basics, we'll be covering how to make location maps, and we'll be doing that using our using built-in coastline data. So as a first step, we'll cover the selections that you commonly need to make in order to create a map using GMT. The first two selections are the data region. So you want to select which region you will be plotting. For example, on the left figure, you have a global region, or if you want to specify the region contained in the darker black box, you would have a subset, and that is always controlled using the -R common option. So it's a common option because it's universal or common to all GMT modules. -R always specifies the region. Similarly, -J is used to set the projection. So you have a three-dimensional space of the Earth, and you want to map that onto either your computer screen or a piece of paper. And that process of creating a two-dimensional representation of a three-dimensional space is done through a map projection. So you use -J to specify how you want your data projected onto that two-dimensional plane. The last option that you commonly will want to specify is the map frame. So that controls settings such as the grid lines, which is you can see on the left, or the annotations, which you can see denoting 40 and 30 degrees latitude on the figure to the right. And the common option for the frame is -B. So in GMT, the -B option is always used to control the appearance of the map frame. So to recap, we have three common options that we've reviewed so far, and they're used to set the region in the case of -R, the projection in the case of -J, and the map frame in the case of -B. And these are the opinionated statement, the most important common options in GMT. So they're ones to remember. And if you don't remember how to control a particular setting with those common options, you can refer back to the GMT documentation, where in the quick links, you can navigate to a table that will take you to each common option. So to go into a little bit more detail about the map projections that are specified through the -J option, we have many different map projections that you can specify using GMT. There's a table, again, that you can get through quick links, where you can click on projection specifications, and it will take you to a table of all the different projections that are available. In general, these projections fall into three different categories: azimuthal, which is projections that fall into a scheme that's analogous or can be thought of as holding a piece of paper tangent to a globe and then projecting from the center of that globe onto the piece of paper. Alternatively, rather than having a flat piece of paper, you could create a cone or a cylinder with that paper and then project from the center outward. And those are respectively conic or cylindrical projections. Most projections fall into one of these three general categories with different nuances to each one. However, there is also a category of projections that are available through a GMT that will allow plotting the entire globe, because you could imagine that these strategies will each not work for different areas on the Earth. And so these global projections are available in order to plot an entire plot the entire Earth. However, there'll be considerable distortion with each, and the distortion is somewhat dependent, or the type of distortion is dependent on which particular projection you include. In addition to being able to inspect these projections more through this table, there's also a cookbook that provides a lot of information about all sorts of concepts in GMT, including detail about the history and specification for each of these projections. So this table is actually contained within the cookbook, and the chapter for -J is where you would get some really fun reading about projection specification in GMT and elsewhere, and with example scripts that you can view in order to see how you specify each one of these projections. We're not going to cover that right now because we'll be doing it, we'll be learning these concepts iteratively live. So in this portion of the presentation, we'll cover the basic format of a GMT script. To start with, we have a line at the beginning that sets the interpreter for your script. So you can verbatim use this line at the top of any script to specify that when you run it, the operating system should use a bash interpreter. After that, we have command GMT begin, and this is the format of GMT modern mode. For all modern mode scripts, you start with GMT begin and you end with GMT end. And then between those two commands, you can have any number of GMT or Unix commands. And to take a quick step back, this format of saying GMT, which is the program name, and then the module name is universal. So if you want to do anything using GMT, you start by typing GMT, and then you type the module name, and then you append any number of options, which are analogous to those Unix flags that we talked about. So that would be, for example, -R is using an option to a GMT module. And each one of those options can take some modifiers. So we have a general structure where we start with the program name GMT, then the module name, and then options and modifiers. So for example, GMT begin takes the, you can append the session name optionally, or the format that you want your graphics, your output graphics to be. So this could be, for example, a JPEG or a PNG. Similarly, for GMT end, you can use show to specify that GMT should automatically open the output with your preferred previewer on your computer. So now that we have the basics for GMT formats, we know where to look for the for help in the GMT documentation. We'll go over a live example of how to make our first map. So I will stop sharing the screen and open up VS Code so we can go over this together. And if anyone has any questions, again, please remember to post them in the Slack channel for those who are joining us live today. And one of the instructors will be happy to help you. Comments in the Zoom chat are much more likely to get lost.
There is one question in the Zoom chat, though, that came directly to me by accident, I think. And it says, is there a PDF version of the cookbook?
I don't think we're doing a PDF version anymore.
No.
Yeah.
No. We quit PDFs some years ago.
Yeah.
However, oftentimes so there's a few different reasons why you might want to use PDF. One is to have everything kind of laid out linearly without having to go to different pages. We don't have much help for that. If it's because you're concerned about offline usage instead, you can, in the bundle, for example, there is built HTML files that you can open in your browser without needing internet connectivity. So for that purpose, we would be happy to offer advice for how to access that without having to go through the internet.
The Windows installer also installs the documentation, the entire documentation. It's only in Linux that it's a separate thing.
Yeah.
Okay, so now we're back in VS Code and we'll go over making our first GMT script. So once again, I am in the GMT for Geodesy repository. This is something that Paul mentioned over Slack, but for those of you who aren't following along, you should, if you're working from the repository, do a git pull so that you get the latest updates. We've been updating the repository and making improvements. So if you cloned it for the first time a week ago, you'll want to do git pull to get the latest changes. I have been doing this, so for me, it's already up to date. So in this repository, I created a new folder, GMT 2022 basics, that we'll be using to create our first GMT script. In here, I'll create a script named italy.sh. So now I have a new empty shell script, and I need to specify so that when this is run, the operating system knows which interpreter to use. So I'll use that line that we had in the presentation. And this is something you can just copy and paste in each time. You don't have to type it, but this specifies that we'll be using the bash interpreter. Also, it's usually a good idea to add some comments to the beginning of your script. And so this is so that if you want to revisit it, you'll know what it's doing. And also so that if you have a folder with many different GMT scripts, you can use tools like the Unix find or combined with grep commands in order to filter your scripts and sort them by keywords. So for example, here we'll say make a map of Italy, and then we could later search for Italy in order to find this particular script, as we've been using GMT scripts for the next 3 days and beyond. So as we saw in the presentation, our GMT modern mode session will be wrapped in 2 commands. We'll first have GMT begin to start, and then we'll have GMT end. And all of the commands within our GMT session will be contained within these 2. We want to specify a title for our image. And so we'll append after GMT begin the name of our figure, which will be Italy. And we also want to specify the figure format. So we'll do PNG as a file format for this case. If we wanted to open the figure automatically, we would use end show in order to specify that that figure should be open. I am going to comment that out so that we can view it inside of VS Code. So anything that is following a # is ignored by the interpreter. So that's how you can add comments to your scripts. So now we have our GMT modern mode session set up, and we'll type in our first plotting command. And for this example, we'll use GMT coast. So we have the GMT program and the module name, which is coast. And then, as we mentioned, we specify the behavior of coast using options or arguments. And so the first option that we'll want is the common option -r. So this will set what the region that we're projecting is. There are many different ways that you can specify the region. One of them is using ISO codes. So we'll do R -r is the common option, and then IT is the argument to that. And this is the ISO code for Italy. So we'll be plotting the region corresponding to the country Italy. As we saw, -B is the common option for controlling the frame setting. So we will leave off any arguments to -B in order to have automatic frame settings. And then for coast, we need one other command, and this is to specify what exactly coast will be plotting. And for this, we want to plot the, we want to color land. So we'll do -G for coloring land, and then we need a argument to this that will specify which color we want to use. So let's color land green. So now we have our first script where we have a single GMT command wrapped within a begin and an end, as usual for modern mode. So we will run this by typing bash italy.sh. And now we have another output, this italy.png, which was created by this script. So if we open it, we see our first GMT map where we've colored land for a region associated with Italy, colored in green with automatic frame settings. Typically, scripting with GMT is a very iterative process. So you will create a map like we just did, and then realize that you want something slightly different. For example, this color green is a little bit bright. So let's make it something more subtle. For example, we can change -G green to wheat. There are many different colors available, which you can sort through or query using the GMT documentation. There's a page that shows each of the colors available. So now if we run this again, we see that we have land colored as a wheat color rather than as a green color. Say we want to also outline coastlines, we can do that using -W. So each one of these options specifies a different functionality for the coast command. And you can find out about each of these again using the GMT docs, but W is the specifier for outlining with a pen. For this module, it's not a common module. So for other modules, it might mean something different. And we want to specify that the pen width should be relatively thin. So now if we run that, we have the default color, which is black in a thin pen setting. So for modern mode scripts, GMT by default chooses a projection that's appropriate for the region. If you want a different projection, you specify that using -J, which is the common option that always means set the GMT projection. Here, we'll use Mercator projection, and you can append to that a figure size. Otherwise, it will choose a default figure size. So for example, say we want it to be 10 centimeters, 10 centimeters wide, you would append 10C. So now you can see that the projection or the method for projecting this region of the Earth onto a 2D plane has changed because we've set, rather than the default projection, to use a Mercator projection, and the size of the figure has also changed. So we'll continue improving this script by adding country boundaries. So for example, for me, my geography is a little bit rough. I'm not sure exactly where Italy ends here. So in order to do that, I can ask GMT to plot country boundaries. And for this coast module, we do that using the -N option. And as an argument, we will do 1, which specifies that we want country borders. And then we'll append the pen specification using thick red. And this, for example, is one case in which there starts to be many different ways that you can control the behavior using arguments and modifiers. And this is not something that you would typically remember. So this is another example where you might remember the -N option controls what borders are plotted, but you'd want to look and refresh exactly how you specify to do country borders and then specify what pen to use. So now we can see the boundaries of the countries in this area. And if we want to have a little bit of space, so you can see that the boundaries of Italy go right up to the edge of the map, which doesn't look ideal. We can use another option or another modifier for the -R common option. So there's a lot of different ways to control the nuances of the region, and we'll use the +R modifier. So a modifier is when you use plus a small letter and then argument after that. So we'll use +R and then 2, which will add some padding to the map around the region that contains Italy. So now you can see that there's a little bit more space here between the edge of the map and the country borders for Italy. If, for example, you wanted to have more granular control over the edges of the map, you could use an entirely different form of the argument for -R. And you can do that by specifying a string with the format, the minimum X value. So here the minimum longitude would be 5 east. And then the second, separated by forward slashes, the second would be 20. So this will have the same maximum X value. And then the same for Y, or latitude. So we'll have the minimum latitude and then the maximum latitude. So now you can see that the longitude range is from 5 to 20 and the latitude range is from 35 to 48. And this is another common way to control what region is plotted in GMT. Another useful component for coast is to actually color the region. So here it's a little bit hard to tell exactly what the focal point of the map is. So we can control that by adding color for the country Italy. So we'll do -E to color a region, specify that the region that we want colored is Italy using the code IT, and then use the +G modifier to specify the color. So you can append red to the +G modifier. So this -E is the option, IT is the argument, and then +G red is the modifier. We'll color Italy red. So now we have a plot where we have colored the coastlines as a black pen, country borders as a red pen, colored Italy red, and we've manually specified the region that we want plotted using the Xmin, Xmax, Ymin, Ymax format. Oftentimes we might want inset map to show some more context for where the particular region we're plotting is. This is particularly important when you're plotting small areas and you want some regional context. So we do that using GMT inset. So we'll do similar to the modern mode session, the insets are wrapped in a begin and end command. So GMT inset begin starts the code that will be plotted in the inset, and then GMT inset end is what ends the code in for the inset. And then inside this, we can have any number of commands that will be created inside of this inset. So for example, GMT coast ... There is a bit more that's required for a successful inset plot. For example, you need to use -D and then modifiers to specify exactly where on this plot the inset will be shown. And so this is just some pseudocode to show you the format. I think this is something we can go over in more detail in the breakout groups. And so what we'll do as we break into our groups is first create a map of your home country or a country of your choice using this format of GMT begin, GMT code, and GMT end. Depending on time, if you've successfully made your map, then you'll work with your breakout session leaders to add an inset. And we'll do this by looking at the GMT documentation, investigating, for example, how do we specify where the inset placement should be using -D? And how do we specify an appropriate region, frame, and projection inside of GMT coast? And then after our breakout groups, we will take a quick break. We'll come back after, or a longer break, it'll be an hour, and then we'll come back and we'll learn how to make GMT subplots. So I'll pass it back to either Paul or Melissa to get us set up in breakout groups.
Yeah, I think Melissa is ready to set that going. So
Yeah, just how many minutes do you think we need to be in the room for before break?
Max, maybe. Let's see. We go
What time is it for you, Paul?
It's quarter to 5 for me. A quarter to 4 UTC, I guess it is. So 15 minutes. That's the break start.
We have a break in 15.
Yeah, that's the long break.
Okay. Well, then we'll be in our breakout groups for 15 minutes.
Yeah, sounds good.
Okay. Got it.
start in a minute or so and everybody gets back online, properly caffeinated or fed.
I had some kaju. Ah. I cannot have both. Six.
All right, we should get starting, I guess. So the next half, or next fat half, starts with more GMT basics with Max for 25 minutes, and then there's a short break, and then we move on to Joachim with lines, and then later with grids with Federico. All right, so
I was already preparing to start.
you jumping the gun.
Not yet, not yet. Not yet.
I'll try to keep it on time so we can get to the fun stuff with lines and grids sooner. So we're gonna start with, I'll try to keep this quick, just a short demo for creating multiple figures and subplots, and then we'll go back into breakout rooms to give it a go on our own. So let's share VS Code again. Okay, so we're in the same repository, and in this first example, we will create multiple figures in the same GMT session. So I will create a new bash script called world.sh. I will copy and paste that same environment specification as the top line, and then we'll create another GMT session, GMT begin, and then GMT end. And we want multiple figures in this session. And to do that, we use the GMT figure module. So this will start a GMT figure, and we will name our figure world1, and we want this figure to be a PNG file. And for this particular example, we'll use the GMT coast module again, because we're familiar with it. Well, the indentation is not required in Bash like it is in Python or some other languages. It is very useful for organizing your scripts. So I do recommend having some indentation to separate your the commands that go in your GMT session and the commands that go inside of each figure. So in this figure, we'll have one command for GMT coast, and we'll have a shortcut -R to set the region, and we'll just use the G character to specify a global region. And then we'll again use -J to set projection, and we'll use a global hammer projection. And the first is argument to this is the central meridian, which will have at 0 longitude, and then separated from the figure width, which will be 15 centimeters wide. And then we'll have automatic grid lines using the -B Karman option and a G to specify grid lines. And then we want to color land purple. And if we give this a run, we now have another figure, which is a global map with land colored purple. And we can use GMT figure as many times as we want within a given session. So now we'll create world 2. We'll do GMT coast again global, except this time rather than D, let's do G to use a different specification of a global map. And we can use the same projection and the same settings, except let's color orange this time. So now we have two figures named world 1 and world 2 with a slightly different plot result. So now we have two outputs, world 1 and also world 2. And the orange did show up. I must have mixed up the shortcut here because it is not in fact, because we need the central meridian to be changed as well. So that actually did not matter because the central meridian was still set as 0. So GMT was smart and did exactly what I told it to do. So now it is a bit different. So now we have the 2 different plots. Okay, so in our second quick demo, we'll go over subplots. So now let's create a new file, worlds instead of world. And in this, we will copy over the interpreter specification. And we will use a new GMT module called subplot to create subplots. So again, everything goes inside of a GMT begin and GMT end. And then we want to specify that we'll be using subplots. And we do that using GMT subplot. And we want to start the subplots using by typing begin. And then there's a few different required information that you need to provide it. First, you need to provide the number of rows and the number of columns. And then you need to supply the figure size using the -f option. And you can either specify the size of the individual subplots or the entire figure. We'll use the lowercase f directive to the -f option to specify the figure size, and we'll make it 15 centimeters wide and 25 centimeters tall. And then use the -a option to automatically label the subplots. And the first command will automatically go in the first of these subplots. And we'll again use a global domain or region and use a hammer projection with 0 degrees central meridian. And we specified the size of the subplot or of the entire figure up here. And we don't want to have to calculate exactly what we want each subplot size to be. So in order for GMT to automatically specify the subplot size, we use a question mark rather than the subplot width. Then we'll use automatic grid lines again and color land. Rather than using a label of a color, we can use RGB specification. Now we want to create another world map on the second subplot. We'll again make it a global map. And this time, rather than using a hammer projection, we'll use a Winkle projection. So -r. Same frame. Make it purple this time, and we need to denote that we want it plotted in the next subplot, and we use lowercase -c, which is a common option that means move to the next subplot. Sometimes tab complete can get you, so you want to make sure that you didn't accidentally tab complete to something else. So, and then for our third subplot, we'll use Moleweed projection. Same central meridian and using a question mark to automatically set the size. We'll color it light gray. We'll color water this time using the -s option with light blue. And again, we want to move to the next subplot using -c. And so if we run this, we will get a warning that we didn't use GMT subplot end, but we can take a look at the output anyways. And so the consequence of that is that the automatic label was not finished. And now, since we added correctly GMT subplot end, we get a nice plot with 3 different subplots in it. So in this demo, you've seen how to create multiple figures inside of a single GMT session, how to create subplots. If you need help creating or working with these different specifications, you can also look at some of the examples that are in the repository that we have here. So let's move back into our breakout groups. And in this section, you can work on either, if you didn't get to creating insets, we can work on creating insets or different subplots where you'll be plotting 2 different regions of your choice.
Okay, we are back in the main room. Max, have completed the session. Anything at the end, Max, before we take a 15-minute break? 10-minute break, sorry. 10 minutes.
Nope, not at all. Thanks everyone for joining for this part, and you'll get to hear from some of the other instructors for the rest of the course.
Yeah, thanks a lot, Max. And if you have any questions about things that we didn't complete, just post them in Slack. We'll get to them as we work through it. But 10-minute break. We start up again at 17:35 UTC. Line symbols and polygons, and Joachim Luis is going to be the instructor. Joachim, you're muted.
Okay.
Yeah, there.
Okay, I'm no longer muted. So okay. Share. Not share. Okay, yes. Okay, so we're going to look at some parts of GMT that are not so exciting at first, or can even be a little bit boring, but there are useful things for us to know is how to plot different lines with different line styles, colors, thickness, all of that. So the first examples will show how to create some of these lines. Maybe not all, because if I spend the time on all of these lines, I might not have time for everything. There was also some questions on some questions on my chat room, and one important information is how to access the manuals. We can access the manuals. We can call the manual page very easily if you remember this command. I'll use the one that gave rise to the question. If we type GMT docs and then the name of the program, plot, for example, it automatically opens in the browser. That works for all the models. So you only have to remember the name of the model, and then you can navigate through the models. Plot, which is the one that we're going to use, is probably not the simplest one to see because it's really long. You can plot a lot of things. Things that I'll be showing are here under the symbols. Symbols is the -s option, and we can do all the things that are shown here and describe it here. It's a very long list of things. So we'll touch in some of those symbols and lines. Okay, this is not the shell that I'll use here. There were also questions on the Slack about on Windows how to call the bash shell. I replied that it never works for me. So I gave up, I don't care. If I want to open the shell, for example, I am in this directory where I have some backup scripts for the things I'm going to show. This is Windows, okay. I will open the bash shell and it automatically is on that directory. And we can now, for example, do another thing, which is to create a blank script. So if we do type -help, I think, -help, you see that we have here an option that says new script. So if I type -new script, it creates a blank script that we can copy or redirect. In this case, I'm going to use the redirection and I will create an empty script that will be called lines.sh. And now in the VS Studio Code, I have more than I want. I have that one that was just created. No, it's not here. Why? Oh, yes. Don't remember anymore why we needed that, but we don't need it in this session. So I'm going to delete this line and see we have an empty script that we can start filling with commands. Right. So the first one, we're going to draw that red line. We need coordinates. Normally, when we use this, we have a file with coordinates, things that we want to plot. In this case, it's syntactic example. So we're going to generate some data. So I'm going to use the echo command to generate a single line. This is 0, 0, if I remember, /e.dat. Not date that txt. No. Okay. Echo then 1 e dot that. So Paul mentioned you, or no, Paul, not Paul, Max. You can redirect the output of a command to a file, and here we are using the echo command that echoes the lines that comes out. So this will create a file called t.dat, and now we can call the plot command with that file t.dat. We have to give it a region, limits for our map. So if I remember what I created was R -11, no, -0, 11. Don't remember, what did I use? See, -1. So I did -1, have some space. -1, 11. Yeah. That's the frame of our plot with the linear projection. X 14 centimeters width. And okay, we want a line. We want it to have a width. minus W, 1 point, and color red. Note, there's some things that are optional, and many times I don't use it. For example, here we're saying that there will be a line with one point, but since points are the default, I could drop the point as well. So what do I have? The line, the color. Oh, let's see the coordinates. Minus B, A, says to automatically decide the annotations and frame. So now I save the file, and on my git bash, I will type lines. Lines. Oh, do I have it? Yes, there is the show at the end, so it should work. Plot did not work. Why? I'm starting to bash. I don't need to give it bash.
GMT plot.
GMT plot. Yes. Yeah. You see about the habits, of course. On Windows, you are not obliged to do that. So that's why I always forget. No, forgot to save. And finally, we got our beautiful red line. So now I want to use another line that will be, let's see what's in the, not this one, oh, not this one. No. Yeah. The red, the thick red line. So I will copy this line. I'm using VI extensions in Visual Studio Code, which is very handy. So now the second time, I no longer need to specify the region and the projection, which makes it simpler, nor the, so I want to have something like 2 and green. Oops, green, green. Oh, and I don't want to overlap the previous line. So I'm going to move it up a little bit. We have an option that says minus Y, and it means to shift the origin of our plot. If I give it 1C, you will move it 1 centimeter above. So this, save, oh, not you, this, see, so we have the red line. So what did we change? The thickness and the color. And we might want to make it different styles, dash it. I think it's what it comes after. So again, copy the line. For this, those of you that know VI will recognize this. It's much more handy than selecting Control-C, Control-V, but each one does as is more comfortable to. So next one will be a blue dashed line. So we want it to be blue. And we want to tell it that the style is no longer a continuous line, it is dashed. So either add dash. We can use dash or we can use minus. They are equivalent. Both of them will work. Okay, here we have it, the dash line. Next, no. Next, we want it dot and dash dot. Don't care so much about the thickness and the color, but so 1. I'm going to put it back to 1, for example. Dot, we put a dot, or we type the word dot. And two of them. Let it be blue, two. We want dash dot, so we put a dash, minus, and a dot. And now we'll have a dotted and a dash dotted line. It's always very far. Yeah. Nope. What is this? Could not. Nope. This is strange. What am I doing wrong? I'm not seeing anything wrong in here. I'm removing the previous ones.
I don't see anything wrong either. But
No. What the hell is this? No, I know what it is. Windows. It comes and goes. I'll explain. Okay.
yeah. Oh,
So my figure was open, the PDF, and it didn't. I'm going to make it PNG. I think you have less troubles with that. Because it was open, it did not let it update. That was that strange Go script error. A little longer. So we have it here. Dash, dot, dash, dot. So, and you can combine, you can do dash, dash, dot, 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 dash, or even more complicated combinations. This one has a difference. You see, the line is thick, but he has round tips. So we're gonna do it again. One, make it thicker. 5. If I drop the color, it will be black and it will be dash. But to make it round, I need to use a new feature for you. Yes, line cap equals round, if I'm not mistaken, but I will confirm with my notes. Round, exactly. Dash it. Yes, line cap. No, yeah, it's a mistake. So see, with PNG, it didn't no longer complain, but now I have more than one open at the same time. So you see, we can make it round with that characteristic of the PostScript lines, which is the line cap. These things are on the manual. You don't remember them. You only have to remember that they exist, and when you need it, find the manual where they are explained. This is how these things work. And this, well, the next line introduces a new type of lines. GMT has one thing called decorated lines. Decorated lines can have many things, like you have in this one. See, you have a text. Now the text was overprinted. You have a line that has symbols put on that line. So you can create many different lines by plotting different symbols along the lines, including plotting text or front lines, which is not in this figure there. So to create an annotated line, I'm going to copy this one. It makes it quicker to see this one, not the other one. See what I'm doing here. Create coordinates for the line. This will be horizontal. I'm going to plot it, and now we have new things. Minus SQ tells it is an annotated line, and it will have 15 labels. Then we tell the font with the plus F. There is a column here to separate one from the other. And then there is the label, and the label here is the tile. I can later replace this for any letter, it would be the same. And then the color thickness and color. Let's see. Yeah. Oh, there is no text. The text is a line of text overprint on that, but I'm not to stand on this. See, you have tiles. If you want some other thing, what we do instead of tiles, we can do hats. Actually, no, it's dollars. I don't know. Imagine that. Not a good idea because it took one and put it in overprinted the other one. Should have only one. Okay. But you see, this is an example. We can plot, and sometimes when we invent comes up nonsense like this, but we can put what we want, not what we want, but a lot of different things in these annotated lines. I'm going to remove the dollar and add a new one that it's probably more useful. This one. So plot again, and this time instead of SQ, we're gonna use the F modifier, which means it plot a front line. They will have symbols separated 1 centimeter and sizes 0.3 centimeters. The symbol will be plus T, means it will be a triangle, and plus L is going to be drawn only on the left side of the line. Let's see. See, and now we have a front line. This is what we use, for example, in geological maps for subduction zones, or in meteorological maps to indicate a cold front, or things like that. There are many symbols that can be used this way, and this is a decorated line, a front line, but this is a decorated line as well, and we can make all these and all the others. So we started with a red one, dull, very dull one, and you can complicate it to make very elaborate lines. You can put text, you can make it curve, can do a lot of different things in here. You have no time to spend in all of these details. Well, I'll jump the two because the time is going, I remember. So start a new one with symbols. Let's do GMT minus new what? Or what? I'm not GMT. New script. GMT, new script, symbols. Same thing. Now I'm gonna open the symbols here. Again, an empty one. And so I'm going to use again the echo command to set up the coordinates. Echo, let me check with my symbols. Okay, 0, 0. If you don't mind, I will copy. So not spend all this time here. So and explain. So we're going to draw a symbol at the coordinates 0, 0, and I'm going to use the pipe and the echo. It means send these coordinates to the plot command instead of telling it to read a file with the coordinates. There will be a region with these coordinates to make it square and with a title. Oh, he has a lot more things. This tells to make a map with a title plus T, and this tells to annotate only the left and the bottom axis. The symbol will be filled with the color green, and it will be a circle. So S is for symbol, C is the code for plotting a circle, and then you need to have the size. In this case, 0.75 centimeters. Let's see. Not this one. And now we type symbols. And the same thing I'm going to do with PNG. So if I forget so here we have our nice green circle filled with the red line, filled with green. If you want to put an outline, I'm going to put an outline. And we're going to move it to the position 1. We no longer need nothing of these, because it was to set only the mark frame. And then it's green, same thing, but we want it to have with a pen, minus W, a pen of 0.5 points. We have it. So we have the same symbol now with an outline. Well, and I can continue. I will not do them all. Since we have an outline, we can do like we did before with the other lines. I mean, move it another position. We can have it dashed. Dash or dash it works both, or minus. So. Again. See, I have it dashed. So I can change, now we can change the color of the line, the thickness of the line. We can do anything we did before. I never tried, but we could even put a front on it or annotated line. You can, all the lines that we draw before can be used to do the outline. So that gives us, if for some reason we want to do that symbol, it can give us gives us the freedom to do all of that. More, consult these. Plot. The manual, the plot manual tells us how to plot all those symbols. For example, if I jump to the star, I will do similar. I'm going to do a star 1, except that now it's position 0, 1, and I will do a star. A star is the code is A. And if you wanted to have a black outline, we have to remove the dash. And you should. This time I'm not moving, this example, I'm not moving with the minus Y and minus X options to move the origin of the plot. I'm using coordinates, which was simpler to make this plot. Okay. Now we have it, okay. So all the time green. So we can select all of the symbols that the common symbols, stars, triangles, inverted triangles, squares, hexagons, pentagons, rectangles, and then rectangles needs more parameters. We can use all of those symbols. The only thing that we have to change is the code for that symbol. And either we remember the symbols is still relatively simple. circle is a C, a square is an S, a triangle is a T, not all the times. An inverted triangle is an I. So when there is available letters, we try to make a mnemonic, although not all the times that was possible. And next we have this line. GMT comes from with some 20 or something symbols. Symbols that have a language that we can create any symbol that we want. We can even use another PostScript image as a symbol, so we can go very deep. GMT comes with some simple symbols that here you have the examples. This one is called flash, so it is on position 0, 3. I go to position 0, 3, 1, 0, 3. The color is what? Is brown, I think, that one. Not make it all the time. And now, custom symbols start with the letter C. And next to it, we need to give it the name, flash, I think. And then a slash with a size. Better to 1.5. I use it 1.5 for that. 1.5. And leave it the outline like this. And see. Oh. Link fielded, not supported. I made some mistake.
SK.
SK, not SC, of course. C is symbol. C is a circle. Yeah, use it. We have the flash symbol. Now, the manual has the names of all the others. Let me put the volcano after and with this one, and also tidy up a little bit of my screen. And put a volcano. It was in position 3, 5. I think it was in 5, but volcano. Red. Volcanoes are red. We all know that. And here we have the volcano here at that position. Further than that, we have some other symbols that they are not in the. I mean, they are used for tests. And so I think I will introduce you to one new thing. This one. So again, I'm going to put a symbol at the position, that position, okay? And then this one is called Galo. But see, he has a hat at the beginning. You will see that probably more times during this course. It is that GMT has some data stored in the servers, and the files that are stored in the server can be accessed with this syntax. You prefix it with a hat. And then the first time it will download from the server and store it in your computer. Next times you will find it in your computer, so no need to spend time downloading it. This is small, but some of them are big. For example, grades, you will see that about grades. So if I'm using these, I'm telling it, go get this symbol, which in fact is a PostScript file that can be used as a custom symbol and plot it with the size of 3.5. And run. And so we have. So this is a PostScript file that can be used as a symbol. So it means I could turn this entire thing into another PostScript file, make it a symbol, and plot it as symbol. So you can plot custom symbols as we want. These ones are simpler, make quicker to make plots when they are longer, but you can have very elaborate things like these symbols here or whatever we decide, as long as we prepare an encapsulated PostScript that will be used as a symbol. So this one, the rooster, is one that is stored in the GMT server, like the sardine here. It's also stored there. It's called sardine, but many others. Well, you have to give it the correct name or a name of some symbol that exists. Otherwise, you can create symbols as you wish with the encapsulated PostScript and use them as symbols. So you can plot, can make a line made of, instead of circles, made of roosters or made of sardines or dragons or whatever we want. So you see these things, then you can go as further as we want in complication. You normally want to make simple things, but sometimes you want to make it more elaborate. And you use these as with the same syntax that you would use to plot a simple circle or a simple line. What did I touch? No, I did not want. Okay. No, come on. Ah. Okay. Oh. Yeah. So I don't know how I am in time. We're going to now see how we plot polygons. How we do this. I'm going to make another new script. This one I'm going to call it also Italian. Well, Italian. Okay. The other ones were not in Portuguese. So, for example, the shape of Italy is very used in our examples. So, and where is it? Italia. Also, explain these, and to use an example, instead of having a polygon that you would have to find the file and put it there in the server for us to use, we can generate a polygon, which is the coastline, the shape of the Italian main continent, without the big and the small islands. That's where this more strange line comes through. So I'm going to put it here. No, here. It can be inside the GMT begin or not. This is not a plot command, so it makes sense to have it outside of the GMT begin command. What does this do? It takes the Italy country, the IT is the ISO code, and use the -m. It is an option that says instead of plotting, just dump the coordinates of the countries. And then because there were many small islets, there is this strange here, more strange option that says only keep polygons that have more than 3,000 points, just to drop the small islets. And another one that's also an introduction or something, we normally, by default, GMT generates text files, ASCII files. But when the file sizes start to go big, text or ASCII files is not the best thing that we should use. It is better to have them in binary format. So this option here, -b, is telling it to output in floats. It means in single precision. So it will have longitude and latitude, but in binary format. And the output will go to this file here called italy.bin, which we cannot see in an editor because it's in binary. So now we have this will be our polygon. The polygon Let me plot the polygon. Can you see? I try to open the binary. It cannot. So we're going to plot this polygon. This time we are not using the echo command. The data will be in here. But because it is in binary, we have to tell it, we have to give it some information, namely, how many, the number of columns, which is the 2, I, it means for input, and F, it means it's single precision. It's like it was here. Here it was O for output. No need to tell the number of columns, the program knows about it, and we told it to write it in float type. The thing is, this occupies 4 bytes for each value, and it could have been D for double, which occupies 8 bytes. The difference might be significant, especially when the resolution of the data does not allow double precision, so no need to spend the double of the size, file size with doubles. Floats are good enough. So here, but because it's binary, we have to tell it the type of data. Again, the limits of the country, the projection, already saw this. M means Mercator projection. Okay, let me add the C, it's not need. Says annotation, automatic annotation and framing, and see our now already known line will be thickness of 1 and dash it. And light blue, the color. Let me show you one thing more about this. I will do it in the oops. Thing is zoom. The zoom makes the computer much slower. For example, if I go here and I type GMT info, this, oops, no. See? GMT info, the file, again, because it's binary, I need to give it that information. And I'm going to say -I1. And it will give me the minimum and the maximum of this data file rounded to the next one value. If I had used it 0.5, here I would have them in 0.5. So I have now I have the limits of that polygon. Because, okay, assume we start with some data we do not know necessarily what are the limits of our map. And we can use the GMT info to tell us the limits of our data and use that for creating things that we need. So we have it here, and let's run the command. Now it's Italia. Italia. Oh, yeah, PDF. No problem with PDF, it's higher quality, except that cannot forget to close it. Confirm. So the color, sorry, it was not for the line. The color was for the filling the polygon. So we fill it this polygon with the color set by the -G option, and the outline is a line, a dashed line. So it's here. And now we can do some innovation and say, instead of painting it with a single line, a single color, I will comment the first one with a hash. So instead of using a color, let us use a pattern. Patterns, there are 80 patterns or something. The cookbook has a table with all the patterns. They access the patterns with the P and the number of the pattern. I think I use it 32. And then we need the resolution, the DPIs, which is plus R. And we always need some trial in these things, because it depends on the size of your image. If you make it too small, it makes not very nice. So you have to try some ones, and we can do the rest is I have to confirm my and I have to close this one. F. The fill color is an F. So plus F blue. Okay. With these, well, let's see what it does. Okay, this is the pattern. I don't know how quickly to find the table with the patterns in the cookbook, but we have a lot of patterns, and we can make the negative and the positives, give it colors, whatever. So see, now instead of a color, a constant color, we may fill it with a pattern, or we may fill it with an image. If I give it the name of a JPEG image, for example, a small one, it would repeat that image and use it as a pattern. So we can fill the polygons with constant colors, with patterns made of these symbols, so the ones that come with GMT. We can give it an image to use as a pattern, and we can give transparency to this filling, to the filling. You'll see images. There are the examples of the gallery also have it. Ways that you can enhance the country by giving it a color with the transparency. So you see the bottom color plus the color part of the transparent color, and that makes a very nice effect that you can see in some of the gallery examples of GMT. So, and I'm about to finish, I think. Yes, I am, but let's finish by having custom symbol. This custom symbol is on coordinates 14, 39, and we can put the symbol here, adding it to the script. Yeah. So what we need to put plot. The coordinate. Oh, I need the coordinates. The coordinates will be 14 echo 14. 39, I think, or close. 5 plots. No, this is from another championship. I don't need the projection nor the region anymore. Minus S K, and it's called mecha from focal mechanisms. This one is not. You'll see tomorrow. We'll show you about how to plot focal mechanisms, real ones. This one is a symbol that simulates a strike-slip focal mechanism. So for mecha, and the size, don't remember, I can check. What did I use? 3 centimeters. So 3 centimeters. To fill, it's the minus G again. I can put 100. For example, this is a color. It's a dark one. Is that one I used? Is it? Yeah, it was. Means you are specifying a black and white, well, a gray shade, which goes from 0, which is black, to 255, which is white. So this is more black than white, but it's almost at the midway between black and white. And minus W. Oh, I can use what is in the example. We can also give names for the thickness. So we have faint, we have thick. You have several others. I don't remember them all. And this is the thing that we are evolving. We'll try in future to replace many of these one-letter codes by spelling it with a comprehensible word. Minus G will be projection, minus R will be region, and things like that. On line thicknesses, there are, and colors, there are already something like that. So if we say faint, it corresponds actually to 0.25 points thickness. So it should go enough. I need to close this one. And not found. Again, GMT. Here it is. So here we have our Italy kicking out a beach ball to somewhere, and one of the exercises I propose is to plot smaller ones, like to simulate like the movement of this beach ball as if it was kicked by the peninsula of Italy. And Paul, I am in time because
You almost run out of time, so.
Okay, I finished. I just finished.
If you want to do a breakout room, it's be a very quick one.
Yeah, I spend more time. 24, maybe.
I think we should just come back to grids and let people have their break.
All right, thanks, Joachim. So in the interest of time, we can do the group exercise on the kicking of the ball a little bit later, perhaps, but we should take the 10-minute break and then get back in 10 minutes to do grids and images with Federico.
Did we want to do the photo?
Oh yeah, and we're gonna have a photo opportunity, a Zoom version of it for every participant. So Alyssa, take it away.
Well, first, Joachim, you need to, unshare. And then if everybody wants to turn on their camera that wants to be involved in the picture, I can do a couple of screenshots.
You're going to do a mosaic or something like that?
Yeah.
Yes, we should do several.
Yeah. Or shrink.
Okay.
That's 2 screens, I think.
Should have everybody. Let's do 1, 1, 2, 3, smile. And do the second page. Oh, nope. That looks like that's everybody. So we're good to go. You can go on break now.
All right, very good. All right, we'll see you guys in 10 minutes.
Okay.
All right, we're back at 1835 UTC for the last section today, which will be on grids and images, and Federico Esteban will be in charge. Federico.
Hi. Can you see my screen?
Yes.
All right. So now I will explain how to make some grids. How to plot some images and grids from the tutorial. So I will show you how first, this is are the topics that we are seeing. First, we are going in this tutorial, we are working with the GMT remote datasets. Here you can see that there are grids and images that you can use on our server. The same that Joaquin explained, that you can download and you can use them. These files will be downloaded from the GMT server to your computer, and then you can use it directly from your PC. There are many remote datasets. Here you can see all of them. Some geophysical grids, gravimetrics, magnetics, some relief grids, and here are also some satellite image. The first, in order to use them, you have to use this name, where you have here you can see three parts: the symbol, which tells GMT to search the file in the GMT servers, then the remote name we see later, and then the resolution. And in the first script, we will make a satellite image of the Earth. So let's go to the script number 1, Earthday bash file. There it is. So now I will now be writing. I have all my just command out there, and I will just comment them out. So, and then we'll see how each of the commands works. Here are the, so if we see this script, I will run the script, very basic script to make a more wide map of the Earth. So bash. So here, this file Earthday1 was created. Is this basic map? So right now I didn't plot any grid. So the command to plot the grid is this command grid image, grd image. Here is the, in this case, I will use this first command to download the Earthday satellite image, a resolution of 30 minutes of arc minutes. So now I will set the file, run the script again, and here you can see that the file was, the image was created. Here it was very fast because I have already downloaded the file. You can make, if I make zoom, you can see that the file, the image could look a bit pixelated. That's because the resolution is not very good. So another thing you can do is for the plots commands, you can use no, you cannot you don't need to specify the resolution. So in this command, I remove the resolution, and what will happen is that GMT will calculate what is the best resolution for my plot. So I run again. Here, maybe you can see, but the resolution is much better. Now I will add this command to see the information. I run it. Now you can see here the information. You can see here that says that here calculates what's the resolution needed. So here it replaces the command with the 10 minutes of arc grid. And also then I plot the coastline, so you can see that the image is all the national borders are fit very well with the image. So yes, back to the, now this just to plot an image. Then I leave you here an exercise to change to make a map of the night view. You just to have to change day by night here, and if you run the script, we have a satellite image of the night view. So let's go back to the README file. Now let's see the plots. Now for the plots, we have for the grids, we have four grids that we can use. Two of the CHEPCO, SRTM15, and the SIMBA. We're using the SIMBA grid for the plots, and let's see the step number 2 to make a relief map of the Caribbean. So close this. Here again, I will comment out all this main commands. I will leave only these two commands. Here, in the first command, I just define the resolution and the direction and the projection of the map. We are making a Mercator of 15 centimeter wide width, and is the geographic region of the Caribbean. I like to use this command just to set the directional projection. This command do not plot anything. And at the end, I add a command just to plot the frame. So I will frame, and now I run the script number 2. So the file here. This. Forget to save the file. So here is an empty image in an empty frame. So I will use the first script, the first command, sorry. And when run this, is the same. Grid this grid is downloaded, and here is plot. So this with only this command you can make a relief grid your region. Now we will need to add some. We need, but here for these grids you have to use a CPT, which is a color palette table that tells the GMT which color to use for each value. For the relief data, the Geo CPT is used automatically, but there is a lot of CPT that you can use. Here are all the CPT that are available in GMT. So the previous map was done with this CPT, but now I will choose another CPT. To do that, I just to use the option -C and the name of the CPT. Here I will use Oleron, which is this CPT. So you can put the name of whatever of any of this CPT, and you will make GMT will use this CPT to make the grid. So run the script now again, and we'll make this grid, the grid again with the image again with this CPT. I think I forgot to save the file. I save the file now. I run it again, and now I change the colors. Now it will be handy to have a color bar to indicate the relationship between the colors and the elevation. So I will add a color bar. To do that, you have to use this command, GMT color bar, and this automatically will add a color bar to the plot. By default, this is plot here below, but you can change its position by using the -D argument in the same way that for the inset maps. So now I will set the color map outside the map to the right in the middle. And also we can also change another. Here are other options that you can later use to see more details, how to change the default values of the color bar. For example, I can use we use this the last command where I will use automatic values on frame for the values. I will add a legend with kilometers, and I am using W to scale all the values to kilometers. So the value will multiply by this value, and I will get instead of meters, I will get kilometers. I don't like the numbers very long, so now I have just only kilometers. You can see the label on top of the color bar and automatic value for the annotation and the values. And also another handy thing is to add the color bar, and now this to add a high shading. This is very simple with GMT. You just have to use this command -I+D. So I comment this command, yes, and we use this. Is it the same? But I just add -I+D. So this automatically will calculate a file to the density to make this map. And here is the challenge. I will leave you for later how to add shading effect to a satellite image, because you can automatically calculate, use the same command, and just you can use this argument. So later you can see we leave you this script to, if you want to make a satellite image with a high shading effect. Now we'll see how to make contour plots. Is there any doubt? To make contour plots, we have to use the command recount TRD contour. Sorry, and there are many. Yes, let's see script number 4 for this. So the first part is the same, just making a setting here the region and projection of the map. Here I will plot the relief with Oleron CPT and I'll shade the effect, and so now I don't have any contour lines. Just if I want to add contour lines, here I will use GRD contour, and here I put the name of the grid. And GMT by default will set will draw a lot of contours based on the automatically. Is not this. I open the wrong file, the right file. So this is all the contours that GMT draw by default. So it's not very. We have to edit a bit contours to draw. So first I will add -N just to draw the negative contours. So for the bathymetry part, so all the contours in the continents we now draw. So now you can see that I only have contours in the ocean, in the Caribbean Sea. Now also you can see that there are many of these. There are some contours that are very small. So yeah, I want to filter them out. I can use the -Q option, and this will make do not draw the contour shorter than 500 kilometers. Run it again, the script. See that many of these small contours will disappear. Yes, I see it. Yes. So now in this grid, in this image, the contours are drawn every 1,000 meters. So if I want to change that default value, I can use -C to draw contours. For example, in this case, every 200 meters. So I add -C 200. And now I will have more contours drawn. Now there are a lot of contours, but I can, as Joaquin explained before, I also can change the attributes of the lines. So with this command -WC, I will choose this will define the properties of the line. So I will choose the thinnest line 0 to indicate the thinnest line possible. This is the color, and a dashed line. In order to improve the quality of the image, so choose those values. So there is now nicer. And now finally, if I want to add annotations, I can use the -A command, the arguments. So I will ask for annotation every 200 meters. Now I will set the font size to 5, and I will add a black box with a border. And here also we set the lines will draw very thinnest line possible. So I set the file. So here are the contours drawn, and you can see that the contours that have a label are not dashed, are solid lines. Now let's have a group exercise. Here the idea is to make a plot similar like this, where you have to discuss with make a relief map for your country of your choice. You have to use ISO country code to make a country, then choose a projection, make a hill shaded, make a relief with a high shaded highly shaded version of the grid, overlay some contour lines at the color bar. And a bonus, you can change a bit the value of the color bar at the frame and the title for the plot. So this bonus that you might you should read later, which differences with the, because in GMT there are two types of grids. Can be grid lines or pixel lines, the registration of the grids, but you can read it later. So, know if you have any question?
Thanks, Federico. So we can all move to our breakout groups now, where we will have about 25 minutes to work on this exercise, and then we'll reconvene for the last 5 minutes in this main session again. Hi, everyone. It looks like we have everyone back from the breakout rooms. Thank you all for joining today for day one of the short course, where we learned a bit about GMT basics. Tomorrow we'll be going a bit more in depth into some specific topic areas, including in the first session, we'll have seismology. In the second session, we'll go over fundamentals of GMT for geodesy. And then in the final session, we'll have an overview of animations. And we went through a lot of material today, and we will continue to go through a lot of material tomorrow. So please remember that day 3 will be focused on specific projects. So that in that day, we'll have a lot of time available for answering any questions or addressing any issues that you're having. Also, if anyone has any questions between today and tomorrow, please feel free to post them on Slack. And we'll be on the Slack workspace for the next 3 days. But remember that moving forward in your research, if you have any questions, you can also register for the GMT forum, where people are asking and answering questions on pretty much a daily basis. So that is another way to keep in touch after the after we stop being on Slack all the time. So thank you all again for joining today. Sorry, I think that there was maybe an issue, so please feel free to continue the conversation if there's problems with GMT through Slack or through GitHub. So thanks everyone, and we look forward to seeing you at the same time tomorrow for the next session.
It was, Max, I think it was important. Someone had a core dump, so I was telling them to try to open an issue.
Oh, okay, great.
Yeah.
Thanks, Joachim. If you're still here.
I hope you can do it or provide a command, give more information. But it was just that. Okay, see you tomorrow.
See you tomorrow.